Hello there. This is just a bite-sized peek into our comprehensive back-end development course, and I'm all about sharing snippets like this on our YouTube free of charge, so sit back and enjoy the video. But if you're interested in diving deeper, why not consider a Covalence community membership for just $25 a month? It's your golden ticket to a full-stack learning experience, curating all of these videos into a comprehensive course, complete with lecture notes, reference sheets, and challenging labs that are really going to push your learning into overdrive. But the perks don't end there. You're going to unlock the keys to our front end and our React, or my React course as well. Not to mention you're going to have access to live Discord support, meaning you can harass me all you want, exclusive coding events, plus professional assistance for crafting killer portfolios and resumes. Just think of it as your personal coding toolkit, ready and waiting to help you build your future. So check the description down below for a link, and remember, whether you're here for a casual browse or a deep dive, just enjoy the video. All right, intrepid students, continuing our discussion on client-side React code for our Stripe API walkthrough. Actually, no, this is a lecture, not a walkthrough. But let's talk about the fundamentals of how this is going to work. We saw the introduction to Stripe, what it was, how simple it theoretically was to implement into our servers, whatever was required, but the actual front end will be a bit more complicated with the payment intent API. It'll be a multi-step form that requires this process here. If you even look at the React, Stripe React example repo they provide you, even they will code just a use effect that fetches a hard-coded payment intent to their own server. So I wanted to make sure I took it a step further to explain to newbies how this process is going to work. So we already have, from the previous lecture, know our required installations, which are these two for the front end, our Stripe.js, @Stripe.js, and @Stripe React Stripe.js. These two are their front end packages. So like I said, we have that custom script from Stripe that will allow for common fraud protection on our application. We're simply going to ensure it's loaded into the head of our HTML on every page. And it's going to be done so with this simple import statement right here. So more than likely, depending on what project you're working in, you could also take the script tag itself right here. Just look up the latest version, which I still think is v3. Just find the latest version of this script from their documentation and literally just paste it into your HTML page or pages. That's all you would need to do. In our case with the React front end, we can keep it inside of JavaScript to keep our HTML code, like the HTML page, just as bare bones as possible, so we can affect all things on it from our React code. If you're using our boilerplate, you will have source client index.tsx as the entry point to the whole React application. Somewhere at the top of that document or that page, that file, that TSX file, you just have to write import this thing, and it will automatically add the appropriate script tag to the head of the HTML on our index.html page, and we are then good to go. So somewhere in the root level of our React project, we write this import statement, and you are set, folks. So from there's a couple things that have to still happen, right? So we have this particular import here. Now, again, I say this wherever you render an elements component, which I'll get to in just a moment. It used to be a bit more straightforward than this, but again, because of the complexity, I have to show you in smaller parts, and I'll show you how it all pieces together, which again, you can change based on your needs, however you see fit. Okay, so we still need to basically load our publishable key somewhere. Remember, that was that front end key that we can push into our code that informs Stripe servers. This is who's making these requests. So wherever we happen to render a elements component, which is a sandwiching wrapper style component that looks just like this right here. Oh, of course it new lines it like this. How ugly. Whatever. With my zoom level, it new lined the prop down there and it didn't look all nice. So we import this named function from the Stripe library right here called loadStripe. LoadStripe will take a singular argument, which is our string value of our publishable key, which again, you can have environment variables on your front end, but remember, they are not secret. So it's put here, and that's all you need. This will basically connect to Stripe on our front end to their server so they know who's making these requests, and we're going to load that into a variable called Stripe promise or pizza. It doesn't matter what you call it. So this will return a new promise with our newly created Stripe object that Stripe.js will load. And like I said, it's going to be put into as a prop into our elements component. And that's the next step, right? So wherever we're going to be wrapping our checkout components. So wherever we need access to a checkout style element, whether that's their credit card, CV, zip, all that fun stuff. All those things will be inside of a component. In this example, I called it checkout form. This could be a pizza component. It could be a whatever page component. It doesn't matter. Wherever we intend to have and build out our checkout form, it must be wrapped by the elements component that we import from the React Stripe.js library, okay? That is the component that will provide context to the checkout form. The checkout form will be anything wrapped inside of elements will be able to hook into that context and read whatever it needs to read. So this is where we provide a prop called Stripe that takes that Stripe promise that we loaded with our public key in the previous code block example. And the newest API version, a major change from the old way of how I used to teach this with the tokenizing of credit cards, also takes an options prop. The options prop takes an object as its argument. So remember, the first set of curly braces is the escaping of TSX to write inline JavaScript. The second set of curly braces would be, or the inner set of curly braces would be the actual object itself, which can accept multiple properties. But in our case, we only care about one in particular called client secret. So this prop and this object key of client secret takes a string value of whatever our client secret from our payment intent is. So, if you recall from the previous lecture on our express side code, we generate a payment intent via a post request to our servers. It sends a request to Stripe servers. Stripe servers send back a payment intent object. That payment intent object has a client underscore secret property that we then send back to our front end. Let me scroll up to it. That we send back to our front end. And once we get that sent back to our front end, we must provide it into this options configuration object. This will be injected, or rather providing a context that our form can hook into and read from as needed without directly touching our code anymore. That is the whole purpose of these elements wrapper. So again, this uses the React Context API. So if you want to learn more about that, I do have a React course that goes into it and probably some videos on our YouTube channel. But that's more advanced than this lecture requires. But yeah, that's exactly what's going to happen. Okay, so now that we have that kind of like baseline idea of how this works, what do we actually have to write here to make this work? Because clearly, I don't just get the client secret written or pasted into our code. I'm going to have to make a request to a server. So how are we going to write this out? So we're going to have a donate route with React Router DOM that loads a multi-step form. We're going to keep it with a simple if-else conditional re-render. If an amount hasn't been set yet, what we do is we have a user fill out an input, the amount they wish to donate, or it would be like the amount a shopping cart value has, saying, I want to proceed to checkout. I have finished purchasing the items I want to purchase. It would then take that amount and send it to our server. Remember, the payment intent gets created, it gets sent back. We get that payment intent, we either set it to a ref or state or something, and then we feed it into this elements component, and then we render our checkout form with the appropriate values. So here we go. Like I said, we're going to have some kind of donate view in our code. Remember, this is how I chose to implement it for this walkthrough to try and teach y'all. This is not how you have to do it. I will try and be cognizant as I'm explaining this code of what's required and what I've chosen. But basically, we're going to have some kind of checkout form component that will actually be rendering the payment elements of the credit card number and etc. The only way that can render correctly, though, is if it's provided a Stripe promise and appropriate client secret for the payment intent API to work. Load Stripe and elements we had just discussed in standalone code blocks so we can kind of digest their purpose, and now we can actually see them implemented. So there is something as an example. I put my publishable key here. So honestly, after I redo these videos, because I was working on it on my end, and I copied and pasted it over here, and I told myself, hey, remember to go ahead and replace that publishable key. Whatever. This is my test key. I re-roll them after these videos anyway, because I don't want to be getting trolled by students, so I have to re-roll keys every single time I make these kinds of lectures. It's very tedious to do, but I got to do what you got to do, right? So what we're going to have is, like I said, load up our Stripe with our publishable key. Again, this should be yours, not mine from this lecture. I'm going to make sure the lecture, you know what? I'm going to make sure my lecture notes don't have this added in here. So, go ahead and try and pause the video and copy and paste it in there, or write what you see in there. By the time this video even goes live anyway, it will be re-rolled and not available for you. So there we go. #professional. So there's our publishable key. There's our Stripe promise. I chose to make a controlled React input controlled by this key of amount. And I have a couple different things here. And again, I chose to do it this way to make it painfully obvious the goal here. Are we setting a donation amount? Which will be true. That'll be the first part of the form. Input an amount you wish to donate so we can create a payment intent. Once that toggles to false, we then swap to the checkout form. This is our toggle for the two-step form we're going to do here. There's multiple ways you can do this. I could also use if this client secret is provided or not as another way we could do so. It doesn't matter. The client secret will be something I need to store to provide to my React components across renders. I choose to do it via a state object right here to keep things nice and easy. So here's the process. Let me show you down to the render. Of course, all these values because they wrap all strangely. There we go. Okay, let's take a look here. So we have a conditional render. We could do a standalone if. I chose to do an if else just to make it painfully obvious what's happening here. If donation show is true. So donation is the state, dot show is the Boolean property. If that value is true, I wish to render a very simple form with a single input that allows us to input a value that we're going to be making a payment intent. So this is a controlled React input. There's nothing magical about it. Remember, this is a different way of calling our set state that provides a callback that says, hey, take the previous state because it's an object of multiple properties. And I want you to set the amount as the eTarget value without losing every other property, aka show and client secret. So that's a little callback set state version we have there. Then we have a button that simply on click will handle the payment intent workflow. So what's going to happen is handle payment intent will prevent the form from refreshing the page because we have a button inside of a form that submits it. We want to prevent that behavior. You could also add type equals button to your button to prevent that as well. We make a request to our server payment intent, post request with JSON content to kick on our express JSON body parser. That's where we get rec.body.amount from. For the request body, I'm going to stringify an object with property amount. I'm going to take the current donation amount and convert it to a number to make sure I don't do any kind of weird string concatenation or something like that instead of actual multiplication or addition. So I'm going to parse the amount, which is going to be a string because it's an input value, to a number and send it to my server. That is where our server gets rec.body.amount from. You should hopefully understand that fairly well after our last couple Express labs we've done here and all the full stack apps you've been coding until this point in the course. So what that is going to do is make a request to our server. Our server then talks to Stripe. Stripe sends back the payment intent. We extract the client secret, send it back to our client end. And that's where this comes in. So we parse the JSON response from the server. You should probably have, if res okay, some error handling. I chose not to add it to keep it a bit cleaner here. So we then extract the client secret from the response. We set our state to maintain the amount that was coded in case we have to go back or something. The client secret is now set with some ES6 shorthand, and then I toggle show from true to false. So when that conditional render toggles, it goes down to else, and here's where we see our elements with our Stripe promise and our client secret added to it as props that will wrap our checkout form. This process has to happen with how React Context API works. Otherwise, you can't just wrap, say, oh, Luke, couldn't I just take elements and put it directly in the checkout form? The way context and hooks work, you can't do that. So we'll have to load it up here, wrap our checkout form, and then render the checkout form. Let's go see that component now. It is fairly straightforward. We bring in three things from the React Stripe library. We see two hooks, use elements, use Stripe. Use Stripe will grab the props of the client secrets and the Stripe promise that we provided right here from our elements component wrapping our checkout form. That's how I can hook into and use those values without directly touching our code. Use elements will be the hook that allows us to confirm we have a configured payment element, which also will read values from the elements component, to make sure that those elements that handle somebody's sensitive credit card information never touch our code directly. It'll instead communicate with Stripe servers. Stripe servers will give us a way to handle it in our code instead. So that's what's going to happen. This grabs the credit card information in a safe post-Stripe modified world. UStripe simply hooks into our context the elements provider gives us. Payment element is the actual component that renders credit card info on the screen. We have different ones we can import for individuals. I believe there's like payment element credit card, one for CV, one for zip, etc. Payment element encompasses all of them and can be styled to your needs. Simply go to their API, their documentation, and look at the payment element component and how you can style it. They have examples. So here's our checkout form component. For some reason, my brain short-circuited there, and I thought I was inside my click function. And I was like, I forgot to call the hooks. Now, they're right in front of me, dude. So, hook into our connected client in Stripe context provider. We're going to call UStripe. It returns a Stripe object to us. Hook into the individual element or elements they give us for credit card info via UseElements. Boom. Our two hooks are called out at the top of our form. That is exactly how the rules of hooks work, as you know from my React lectures. So let's actually go down to the render and look how simple it is. Look at that. Even the form is optional. I can just put in payment element and a button and I can call it a day. I render payment element. Remember, this handles the credit card info and makes sure that it never directly touches our code. That's all we need right there. And a button that will confirm the donation and fulfill the payment intent we've received. Because remember, by the time this thing renders to the screen, we have the payment intent client secret already created and stored in our React code ready to go. So what happens when the button's actually clicked? We make sure that if our hooks have failed to consume this provider's context, it should not continue because it's not going to work. So if we have if Stripe or elements, the two hook variables, have not been successfully created, then we probably shouldn't run any of this function and stop it dead in its tracks. That's what's going to happen there. And you could choose to log in a debug error message for yourself if that occurs. From there, we ask our hooked in Stripe to confirm a payment with the credit card information found in the current elements we've hooked into. And this will attempt to confirm a payment on their servers. So it's going to fulfill the payment intent we created from the previous step. If that succeeds, it's going to then say, I want a confirmation return URL to go to wherever I want. Maybe you have a /confirm or /thank you page that you're going to redirect to. If not, do whatever you want. It doesn't matter, right? So I can say return URL, go nowhere, and just have an alert pop up here, for example, after this succeeds. In our case, we can always have it go to a /thank you page or something like that. But that's what's going to happen. If this promise succeeds, it's going to redirect us to wherever we want if we want to. Otherwise, we can specify some code after the promise to run instead, like popping an alert or a modal or something that says thank you if we want. But we can also do some error handling. We can destructure the error object off of the confirm payment should one occur, and this is some error handling that their documentation recommends. If there's a card error or validation error, console log the error message. Otherwise, we don't know what type of error happened and something major on their end or our end occurred and it just says unexpected error. So again, this comes from their documentation. If you want some specific error handling, this is how you can handle it. But from there, like I said, rendering it is simple. This is all the credit card info is handled here internally on them. They have the compliance on their shoulders, not us. We hook into it with this hook use elements right here, and then we just pass the elements into the Stripe confirm payment function, which will then handle all that process for us. That is how their CC info is never touching our code directly. It's all handled via the Stripe code. And that's it. That's all that happens. These lecture notes will be a good reference material for y'all to come back to. So for example, you can come and check out the bullet points that are all written down here for every single piece of code. They're going to be just going over exactly what I've said and workflow of what I've been saying so far. So I'm not going to rehash by reading all of them. There will be just basically a quick lookup for you to make sure you understand the process. Because remember, this is not how you have to do it. This is just a way to do it with their new API. But I want you to understand the fundamental workflow because you can implement it however you need on your particular e-commerce store, since this is like a fake donation form, for example, for our labs. Now, testing. You need to be able to provide a credit card with proper expiration date and security code. That is done by simply alternating 4242424242 as many times as possible, and that will be a Visa testing card that you can actually charge and see in your Stripe developers portal. You will see these pending charges. I'll have several from today when I was preparing for this lecture and walkthrough series, right? So if you want to test other kinds of cards, you can do so by going to their testing documentation, and I'll show you other ways to test it. We're going to be using the 4242 method for testing a Visa card, and that's it. So wrapping up, aka my TLDR that you can also use as a quick reference. Donate component collects a donation amount from the user and sends it to the server to create a payment intent using Stripe's API. That creates a pending payment in the Stripe dashboard and returns a client secret to our server, which then daisy chains it back to the front end. The client secret is then injected into the elements component, which renders the checkout form after that process is done. The checkout form displays the payment element for entering credit card information and confirms payment when the user submits the form. The payment element ensures the credit card information never touches the application code by sending it directly to Stripe's servers, along with the client secret and payment intent to fulfill the transaction. This process ensures secure handling and processing of credit card information using Stripe. Congratulations, we've gotten through the lectures. The fun part is coming up next of actually coding all this out. So while the code will look almost identical to this with a couple additional pieces of style on there, we're going to code one from scratch together anyway in a walkthrough on a fresh clone of my ES-Build boilerplate to make sure that we can code it and understand what's happening and not just look at this and go, yeah, I get it, and not actually get it. So we're going to code it together in our walkthrough, and the lab will have you add it to one of your full stack labs, such as the blog full stack lab, add a donate route there and stuff like that. So that's what's going to happen. The lab's going to ask you to add it to one of your existing projects, but the walkthrough, we're going to code it onto a fresh project and call it a day. So if you want to use the one from our Mailgun walkthrough, you are welcome to do so. I'm going to make a fresh clone of the boilerplate and set up everything and get going as fast as possible. So I'll see you all in the next video when we actually start tackling this fun implementation.